Welcome to everybody to another physics video. In today's class, we're going to go ahead and discuss the examples of bad and good best fit lines, and more importantly, how to calculate slope the proper way using the correct equation. First, we have a bad example of what not to do in some graphs. And when you're drawing best fit lines, you do not want to connect the dots. Another bad example is don't just draw a line from the first point to the last point. So this is the student's first data point, and this is their last data point, and they've simply taken those two, and connected them in one straight linear line. And finally, always use a ruler or straight edge. The straighter your line is, the more accurate results you will have. Okay, our first good example is you should go ahead and try to touch as many points as possible. It may never be possible to touch every single point. So the key thing is to touch as many points as possible as you can. For example, this one's not touching and this one is not touching either. And that's okay because those data points, there might have been some error issues in the reading, and that's why we do a best fit line. Another tip to have is to try to have equal number of points above and below the line. Now, this is not possible to have at all times, meaning an even, exact 5, 5, or 3 and 3, but try your best to keep it as close to each other as possible. What you don't want to have is have 10 data points above the line and only 2 below the line. So keep that in mind. Try to have roughly around equal number of points above and below the line. As we see here, we have 2 below it. There's 4 touching, and technically these 2 are above. That one's right on it. This one's below it. But we have about 4 touching and 2 below it. Another thing that you want to do is you want to always go ahead and extend the line as far as possible. And that should include going past your last data point, which is here, and also past the y-axis as well. Or if it happens to be crossing the x-axis, you should be crossing the x-axis too. So don't just stop short, but instead extend your points as far as you can. All right, how to find a slope of a line, or any linear line for that matter, and using the proper equation. All right, we are never going to use that method. I'm not going to even mention that method. However, that method is going to be wrong every single time in your physics classes. I know your algebra teachers may have taught you that, but that's because they do it purposely and set up the graphs with even increments, which is the only way that method works. So that method will not work in physics. Instead, use the proper equation, which is m is equal to y2 minus y1 over x2 minus x1. Or essentially delta y, the change in y, over the change in x. Again, if you count the squares to find a slope, your answer will be wrong. So whether you attempt the question at all or simply attempt by counting boxes, you're going to get the same amount of points, which is 0. So if for whatever reason you are tempted to count boxes and use that method that is so ingrained in your head, just remember, save yourself the time. You're going to get a 0 anyway. All right, in order to find a slope, you're going to pick 2 places where the line looks like it passes through the corners of a square of your graph, and you can easily read those. So good values are these and this one here. You're going to go ahead and mark the spots on the x-axis and the y-axis, or essentially where the coordinates are. Notice we didn't use our data points as our slope because you do not want to use your data points for best fit lines. And what you want to do is you should always go ahead and draw little lines and cross all the way down to x-axis and into the y-axis so that you can read your lines properly. Do not eyeball, as it leads to many errors. So we're going to go ahead and find the change in y and the change in x. Our first point is going to be the one all the way to the left, and then anything after that, the next point that you decide to use will be considered your second point. So this will give us our x1 and y1. This will give us our x2 and y2. So we're going to go ahead and take the readings on those. The y coordinate on this value is, if you go all the way to the left, it is 4.5, and the x value on this, if you go all the way down, is 6. Likewise for this one here, the y value is a 0.5, and the x value is 0. So y2 from this one is 4.5 minus the 0.5 from the y1 is equal to a difference of 4. Our x value for x2 was a 6. Remember this one here coming all the way down to be a 6. And from this point here was a 0. So 6 minus 0, x2 minus x1 gives us a value of 6. When you punch it in the calculator, 4 divided by 6 will give you roughly around 0.6667, which rounds up to 0.67 meters per rubber band. If you paid attention, on the y-axis, they were measuring the height in meters, and on the x-axis, they were measuring how many rubber bands it took for this observation or lab data. All right, again, if you had counted the squares, you would have counted 16 upwards and 16 to the right. 16 divided by 16, your slope would have been 1. So again, that is definitely not the answer, and that is worth 0 points. Save yourself the trouble, save yourself the time. Don't even bother with that attempt. Another bad example is you don't want to find a slope by only using the first and last points. In fact, you don't want to find a slope using any data points. If you remember, we drew our own points that we could read properly. When you're finding the slope on a best fit line or any kind of line, do not use the data points. You also don't want to go ahead and pick two places that are very close together, as this can lead to a large percentage of error. Okay, there you have it. As long as you know how to graph properly and as long as you know how to use the correct equation to find the slope, then you shouldn't have any issues with succeeding in physics. Have a great day.